Hello and welcome to my YouTube channel DM Tricks, quality education for everyone. My name is DM Bage and today we are going to start a new video series on physical world. Physical world is the part of class 11 syllabus and no questions whatsoever are ever asked from this chapter. But still this chapter is very interesting. Here we talk about the very basic nature of physics itself, as in what is physics, what is the scope of physics, what is the method of thinking in physics. This chapter will familiarize you with the very grand nature of physics itself. So let's begin. Whenever we talk about the physical world, the first picture that comes to my mind is the picture of the universe. The entire solar system, the stars, the galaxies, the black holes, etc. comprise our universe. Just think for a while. This universe is so big that our tiny little planet Earth is almost insignificant here, almost like a dust. So we human beings are even more insignificant because we live on the planet Earth. But still, our tiny little brain has the capacity to unlock the mysteries of this universe. This world can be classified into two ways, physical world and non-physical world. Non-physical world represents the spiritual and psychic world which is beyond human perception. It talks about the existence of God, the religion, the heaven, the earth, the dream world, of which we do not have any clear-cut idea. Whatever we know about this world cannot be proved and cannot be disproved either. In physics, we don't deal with such things. In physics, we deal with the perceptible things, the material world which can be seen, observed, or felt. For example, color, shape, atoms and molecules, space and time, etc. Physics is the study of basic laws governing this universe, and our tiny little brain has already unlocked some of the mysteries. Let's take a look. Newton's laws of motion and the law of gravitation describes the motion of any physical body in any part of the universe. We no longer believe in the shits like angels pushing on the planets. Newton's laws gave us the early ideas about the universe. Maxwell's laws of electromagnetism describe all the electromagnetic phenomena. With the passage of time, our knowledge became more and more refined. And we discovered theory of relativity, which changed the perception of space and time once and for all. It gave us a new perspective to look at this world. It gave us a better and more accurate picture of the world. The other promising field of physics are the Big Bang theory that deals with the origin of the universe, the quantum mechanics, which is also very promising. It tells us that this world is much stranger than what we can ever imagine. The most pertinent question is, how do we do it? How does our mind unravel the mysteries of this universe? Let's try to understand this. A very famous physicist, Richard Feynman, says that this world is like a great chess, being played by the gods, and we are the observers of the game. We do not know what the rules of the game are. All we are allowed to do is to watch the game. At the very beginning, when we start watching the game, everything looks quite perplexing and complicated. So many things are happening at the same time, and it almost appears that this game cannot be understood. But if you wait and watch the game for long enough time, you start to figure out some of the rules. Similarly, at first glance, this world looks quite complicated, sometimes terrifying, but it turns out that this world can also be understood. Albert Einstein puts it this way: the most incomprehensible thing about this world is that it is comprehensible. While watching the game, we notice that certain moves always happen in a regular fashion, according to some rules. For example, the bishop taking the diagonal moves, the rook taking the straight moves, the knight taking 2.5 moves. Similarly, all the natural phenomena in this world always occur in a regular and systematic manner, according to some basic underlying laws and principles. For example, the rainbow, the sunrise, the sunset, change of seasons, the rain, and so on, all of these things happen in a very regular fashion. We are merely the observers. We don't make the rules, but only describe it. And for its description, we devise certain concepts. For example, the concept of space and time, the mass, velocity, volume, density, and so on. And in terms of which we formulate the basic laws of the universe. Merely the choice of words doesn't change anything. Einstein once said, "A word means what you want it to mean." For example, if I say that refraction is the bending phenomenon of light at the interface of two media, and someone else says that thingomagic is the bending phenomenon of light at the interface of two media, does that change anything? Both of us are talking about the same thing. Now, we have been watching this game for centuries and have managed to figure out some of the rules. Maybe some other alien civilization is also watching this game. Will their discoveries be any different from us? Certainly not, because we both are watching the same game. We both are talking about the same thing. So, we both will discover the same laws. The laws of physics are universal. Now, let us talk a little about the scientific method. The Mother Nature is very tricky. She's not going to reveal herself to you unless and until she deems you worthy. Just watching the game is not good enough anymore. You need to observe it very closely using very sophisticated techniques. The entire mountain of scientific knowledge that we have accumulated over the years has resulted from a very specific method of thinking called scientific method. Scientific method can be described in three words: observation, hypothesis, and experimentation. Observation involves the accurate measurement of some physical quantities using very sophisticated techniques because you don't want anything to go missed. Once you have collected the raw data, you will start looking for some pattern. If you get it, you propose a theory. The work is not done yet. Your theory is merely a speculation unless justified by the experimentation. So you must devise an experiment to justify yourself. As in physics, experiment is the sole judge of the scientific truth. If the experimentation supports your theory, eureka, you have discovered a physical law, and you will be duly rewarded. Let's see how it works in the real life. One day, you see a rainbow in the sky that puts you into thinking, what is really causing this rainbow? Some other day, you come across a very interesting toy, prism, which can create a rainbow-like effect. You get more interested and start thinking again, trying to connect the dots. Can these two things be connected? One day, you take another prism and put it inverted in front of the first one, and you observe an amazing phenomenon, the merging of the colors. By now, you are convinced that white color is a mixture of seven colors. But still, it is merely a speculation unless supported by experimentation. So you devise an experiment. You devise an ingenious color wheel comprising of seven colors, same as in the rainbow, and start to rotate it. You notice that after a threshold speed, the wheel is turning white, while actually it is not. Seven colors together gives us the sensation of white color. Your experimentation supported your hypothesis. White light is truly a mixture of seven colors. This is how a scientist works. Newton went about discovering these things the same way as described over here. Science is simply the systematic knowledge acquired by the application of scientific method. In this entire context, one thing is very important: the measurement. Without measurement, you cannot have accurate observations. Observations are as good as your measurement. Measurement is truly the heart of physics. We will talk about measurement in the next video. Till then, happy physicsing.